Tonight, we uncover the moment the golden eye of humanity peered into the dawn of time and found a reality that technically shouldn't exist. For decades, we were told the story of a slow, cooling universe, a cosmic nursery where stars and galaxies took eons to crawl out of the dark. But the James Webb Space Telescope didn't find a nursery. It found a battlefield of fully grown giants. When the first data streams hit Earth in the summer of 2022, the room at the Space Telescope Science Institute in Baltimore went silent because the numbers didn't just challenge our textbooks, they detonated them. Now, a Nobel laureate is warning that our entire map of the heavens is fundamentally broken. We are seeing galaxies that are too massive, too bright, and too evolved for the era they inhabit, existing in a time when only chaotic smudges of gas should be present. It is a mystery that has moved from the pages of scientific journals to the edge of existential horror. Are we looking at a universe far older than the 13.8 billion years we've been promised? Or have we accidentally stumbled upon the fingerprints of another universe altogether? Imagine you are an archaeologist who has spent your entire life studying the slow, painful progression of human technology. You know for a fact that complex cities with plumbing and electricity only appeared after thousands of years of small settlements and simple stone tools. Now imagine digging into a layer of earth you know is 10,000 years old, expecting to find flint, arrowheads, and bone needles, and instead your shovel hits the polished steel of a modern smartphone. That is the level of profound, fundamental shock that hit the astronomical community when James Webb opened its golden eye. We call this the impossible galaxy problem, but in the private circles of cosmology, it is known as the moment physics broke. According to the standard model of our universe, which we have carefully constructed over the last 50 years, the first few hundred million years were supposed to be the cosmic dark ages, a quiet, primitive era where the first Lego bricks of matter were just beginning to snap together. You simply cannot have a majestic, fully built castle when you haven't even finished manufacturing the bricks. Yet James Webb looked back 13.5 billion years and found cities of light already burning with the intensity of hundreds of billions of suns. The epicenter of this crisis is a galaxy with a technical name that has become a symbol of our misunderstanding, JADES-GS-Z14-0. We see this object as it appeared only 290 million years after the Big Bang. To put that in perspective in the context of the universe's overall life, this is a newborn captured in mid-formation, the cosmic equivalent of a baby taking its first breath. But JADES isn't behaving like a newborn. It is a monster. It spans over 1,600 light-years in diameter and contains hundreds of millions of suns worth of stars. It is bright, it is organized, and most disturbingly, it is chemically advanced. When astronomers analyzed the light from this impossible galaxy, they found traces of oxygen. This shouldn't just be difficult to explain, it should be impossible. Oxygen is a heavy element that can only be forged in the nuclear furnaces of stars. For oxygen to exist in such abundance so early, a previous generation of stars had to be born, live through their entire lives, and explode as supernovas to seed the surrounding gas with their remains. The standard timeline says this process takes billions of years. JADES did it in a fraction of that time, as if it had been given a cosmic head start from a reality that predates our own. This discovery has created what scientists describe as a quiet panic. For 40 years our predictions matched the sky, but suddenly the map no longer matches the territory. In the standard story, gravity is patient. It takes a long time for cold, dark matter to build the invisible scaffolding of a galaxy, and even longer for gas to settle into that scaffold to ignite the first stars. This is a bottom-up process, moving from small, disorganized clumps to the massive structures we see in the modern sky. But James Webb is showing us a top-down reality. It's as if the skyscraper was built before the foundation was even dry. One scientist famously compared the feeling to looking at a baby photo and seeing a fully grown adult staring back at you. It suggests that the cosmic clock we have been using to measure time is fundamentally misaligned. The implications of these universe breakers are staggering and branch into three terrifying possibilities that the original textbooks never dared to mention. The first is the most straightforward but perhaps the most disruptive to science. The universe is much, much older than we thought. If the age of the universe is closer to 26 billion years rather than 13.8, then JD's and its massive cousins have plenty of time to grow. But if we have been wrong about the age of the universe by over 10 billion years, it means our understanding of the Big Bang, dark energy, and the expansion of space is not just slightly off, it is fabricated. It would mean the very foundations of modern physics are built on a mathematical illusion. The second possibility is where the law vault of cosmology gets truly dark, the hidden physics window. This theory proposes that for the first billion years after the Big Bang, the laws of physics were not the ones we know today. Perhaps gravity was stronger, or the chemistry of primordial gas was so different that it allowed for a flash of super-efficient galaxy building that we can no longer replicate or observe in the modern era. It suggests that our universe has settings that can change, and we are living in a stabilized version of a much more violent, much faster original reality. But it is the third possibility that has fueled the most intense speculation, that these impossible galaxies aren't from our Big Bang at all. They might be relics or artifacts of a lost aeon, leftovers from a universe that existed before our own. Sir Roger Penrose, a Nobel laureate, has long argued for a cyclic universe, where the end of one cosmic era triggers the birth of another. If this is true, the skyscraper Webb found in the dawn of time isn't a miracle of fast construction. It's a ruin from a previous world that managed to survive the phase shift into our own. We might not be looking at the beginning of time, but the wreckage of a previous reality bleeding through the cracks of our own Big Bang. As astronomers stay up all night running simulations that continue to fail, the realization is setting in that JADES-GS-Z14-0 is not a glitch in the data. It is a signal, it is a warning that our perception of reality is limited by a story we told ourselves to make the universe feel predictable and safe. We thought we were measuring the dawn of stars, but we might actually be witnessing the rendering errors of a much larger computational system, or the nested layers of a universe existing inside the event horizon of another. Every time James Webb sends a new image of a mature, glowing spiral galaxy from the era of infancy, it pulls at a loose thread in the fabric of cosmology. And as that thread unspools, we are finding that the skyscraper in ancient Rome is just the beginning of what the golden eye is about to reveal. The crisis isn't that we are wrong, it's that the truth is far weirder than we were prepared to believe. We aren't just rewriting textbooks, we are witnessing the collapse of a scientific empire, and in the debris of the old model, a new, terrifyingly vast reality is finally speaking back. In the hushed corridors of high-stakes astrophysics, there is a name that commands a specific kind of reverence: Adam Rees. He is not a rogue theorist or a sensationalist looking for headlines. He is one of the primary architects of our current reality. In 1998, Rees co-discovered dark energy, the invisible force that is currently ripping the universe apart at an accelerating rate, an achievement that earned him the Nobel Prize and forced every textbook on Earth to be rewritten. He is a man who spent his life building the very rulebook that is now, inexplicably, failing to match the data. When someone of his stature looks at his own measurements and says, quietly and without drama, that we may have misunderstood the universe, the scientific community doesn't just listen, it feels the floor beneath it begin to liquefy. This isn't a minor disagreement over a decimal point. It is a declaration that the foundation of our cosmic map might be a fundamental illusion. To understand the weight of this warning, you have to understand the number that is currently breaking physics, the Hubble constant. This single value is the heartbeat of the cosmos, a number that measures exactly how fast the universe is expanding at this very second. It determines the age of everything, the size of the observable universe, and ultimately, how it will all end. For decades, we thought we were closing in on the final answer, But instead, we stumbled into a scientific civil war, a conflict so fierce it has split the field of cosmology into two warring camps that are currently looking at the same sky and seeing two different realities. This is the Hubble tension, but in recent months it has been upgraded to something far more dangerous, a full-blown cosmic crisis. The first camp in this war looks backward, staring deep into the past toward the very first light in existence, the cosmic microwave background. This is the baby picture of the universe, a faint glow of radiation released just 380,000 years after the Big Bang. By using the Planck satellite to map this ancient light with extreme precision, scientists can calculate the exact conditions of the infant universe. They then plug those conditions into our standard model of physics and run the clock forward nearly 14 billion years to predict how fast the universe should be expanding today. The math is tight, the equations are elegant, and the prediction is clear. The expansion rate should be about 67 kilometers per second. This camp represents the blueprint of reality, the logic that says if the beginning was A and the laws of physics are B, then the present must be C. The second camp, led by Rees and his team, refuses to rely on predictions. They don't look at the beginning, they look at the here and now. They build what is known as the cosmic distance ladder, using real stars and real explosions as physical markers in space. They start with pulsating stars called Cepheid variables and move outward to Type 1 as supernovae, exploding stars so bright they can outshine entire galaxies. This method is direct, tangible, and relies on the physical ruler of the modern universe. And the ruler is telling a different story. Every time they measure the expansion of the nearby universe, they get a number close to 73 kilometers per second. A 6% gap might sound like a rounding error, but in the precision-obsessed world of cosmology, it is a chasm that threatens to swallow our entire understanding of time. If the expansion rate is 73 instead of 67, the universe is not 13.8 billion years old. It is more than a billion years younger than we've been told. 1 billion years of history erased in a single calculation. This discrepancy implies that something is fundamentally missing from our equations, an unknown force, a hidden ingredient, or perhaps a different kind of physics that existed only in the early universe and has since vanished. For years, the past camp argued that Rees's present method was simply flawed, that dust, or the limitations of our telescopes, were creating a 6% illusion. Everyone expected that when the James Webb Space Telescope opened its golden eye, its superior infrared vision would fix the error and bring the expansion rate back down to 67. They expected the tension to dissolve into a footnote of scientific history. But the universe had a darker plan. When the first data streams from Webb arrived, they didn't just confirm the higher number, they validated it with terrifying clarity. The error wasn't in the instruments, it was in our reality. This confirmation has turned the Hubble tension into something much deeper than a measurement problem. Within the law of speculative cosmology, this persistent 6% gap is starting to be viewed as a rendering artifact, a glitch in the code of the universe that appears only when you compare the initial state of the system with its current output. It is the cosmic equivalent of a digital simulation where the physics engine for the early levels doesn't quite match the processing power required for the later stages. If Rees is correct and the tension is real, it suggests that the standard model isn't a complete description of the cosmos, but rather a local approximation that is failing at the edges. The scientific civil war has now reached a fever pitch. On one side, you have the Planck pillar, the defenders of the Big Bang's first light, who insist their blueprint of the infant universe is too precise to be wrong. On the other, you have the Rees ladder, the observers who argue that you cannot argue with the physical light of stars that are burning right in front of us. Between them lies a void where our understanding of time used to be. As Rees himself has suggested, measurement errors have been ruled out. We are left with the exciting and deeply unsettling possibility that the story we have been telling ourselves about how the universe grows is fundamentally incomplete. We aren't just missing a piece of the puzzle, we might be trying to build the wrong puzzle entirely. The golden eye of Webb was meant to settle the score, but instead it has signed the death warrant for our old certainty, leaving us standing at the threshold of a universe that is far younger, faster, and more mysterious than we ever dared to imagine. If the Hubble tension is a fracture in the global map of our universe, then what James Webb found next represents a haunting of the local neighborhood. As astronomers moved past the shock of the universe breakers, they began to notice a much more pervasive and perhaps more disturbing population of objects scattered across the deepest fields of the cosmic dawn. They were not sweeping spirals or majestic elliptical giants. They were tiny, intensely red, and seemingly everywhere. The team quickly gave them an unofficial nickname that has since become a staple of scientific intrigue: the little red dots. On the monitors at the Space Telescope Science Institute, they appeared as nothing more than crimson pinpricks, smaller than a single pixel, yet they radiated with a concentrated energy that defied every model of stellar evolution we possess. We are finding hundreds of them appearing in an era when the universe was only about 500 million to 1 billion years old, glowing with an intensity that outshines entire galaxies 10 times their size. These are the ghosts in the mirror, and the more we study them, the more they look like artifacts of a physics that should not exist in our reality. The first instinct of the scientific community was one of skepticism, a desperate search for a natural explanation that would preserve the standard model. When you find an object that is far too bright for its estimated mass, you look for the optical illusion that is tricking your senses. To explain this, astronomers introduced one of the most famous analogies of the Webb mission: the flashlight taped to a candle. Imagine standing on a dark, foggy highway and seeing a light in the distance that appears to be a massive, glowing bonfire. Based on its sheer brightness, you calculate that there must be thousands of logs burning in that pile to create such a blaze. But when the fog clears and you get a closer look, you realize you were looking at a tiny, flickering candle with a high-powered tactical flashlight taped to the side of it. The flashlight is a supermassive black hole, or an active galactic nucleus, and the candle is the small, early galaxy surrounding it. The intense friction and heat of gas spiraling into the black hole creates so much light that it bleeds into the starlight, making a small cluster of stars look like a massive cosmic giant. This was the correction that was supposed to save us. If the little red dots were just hungry black holes inflating the apparent size of their galaxies, then the impossible galaxy problem might shrink. We could stop panicking about galaxies being too big too early because they weren't actually big, they were just brightly lit. For a brief moment in early 2024, the field breathed a sigh of relief. But in science, sometimes the solution to one mystery reveals an even deeper, more terrifying abyss beneath it. Because while the flashlight theory explained the brightness, it introduced a contradiction that shattered one of the most fundamental rules of the cosmos: the law of proportions. In the modern universe, there is a cosmic law that is as reliable as gravity itself. It is the rule that a galaxy and its central supermassive black hole always grow in perfect rhythmic synchronization. In every galaxy we have ever measured, from our own Milky Way to the distant clusters of the local group, the central black hole typically weighs about 0.1% of the total stellar mass of the galaxy. It is a tight, predictable ratio that suggests the two grow together like a tree and its roots. But Webb's little red dots didn't just bend this law, they obliterated it. Spectroscopic analysis of the gas moving around these crimson dots revealed speeds of nearly 1,000 kilometers per second, confirming that there were indeed monsters at the center. But the mass of these black holes was not 0.1%. In many cases, the black hole appeared to weigh nearly as much as the entire host galaxy itself. In some instances, it was 100 times larger relative to its galaxy than it should be. This realization has fundamentally inverted our understanding of cosmic history. According to every textbook, the galaxy is supposed to form first, slowly gathering gas and dust over millions of years, and then the black hole grows as a byproduct of that evolution. But the little red dots suggest the opposite. They suggest a top-down reality where the monsters came first, where massive, billion solar mass black holes were seated in the void before the first stars even had a chance to ignite. It is as if the root was grown before the tree, or a massive city monument was built in the middle of a desert before a single house was constructed. Finding these black holes so early is the cosmic equivalent of discovering a fully grown whale inside a fish egg. There simply hasn't been enough time in the 13.8 billion year timeline for a stellar mass black hole to grow that large. It would have to feed at a rate that breaks the Eddington limit, the physical speed limit for how fast a black hole can swallow matter without blowing itself apart. This leads us to the most provocative implications found in the most obscure corners of the law vault. If these black holes are too big to have grown in our universe, where did they come from? One emerging theory is that we are looking at primordial seeds, objects that were formed not by the death of stars, but by the direct collapse of massive gas clouds in the first fractions of a second after the Big Bang. Or, more disturbingly, they might be relics or fossil structures that managed to survive a phase shift from a parent universe. Under the nested universe hypothesis, our Big Bang wasn't a beginning, but a transition, a moment where we were birthed inside the event horizon of a black hole belonging to a much larger reality. If that is true, the little red dots aren't just galaxies, they are the umbilical cords of our reality, connected to a scale of existence we are only now beginning to perceive. The mystery deepens when you look at the quantity and isolation of these objects. Webb has identified over 700 of these targets, and many of them sit in cosmic voids, regions of space where there should not be enough matter to feed a growing black hole. They are sitting in the middle of a desert, yet they are morbidly obese. This isolation contradicts everything we know about black hole growth, which usually requires a dense environment with plenty of food in the form of gas and merging galaxies. This has led some fringe theorists to speculate on the civilization filter theory. They argue that these compact, ultra-luminous objects don't behave like natural galaxies at all. Instead, their compact size, extreme energy output, and lack of expected X-ray signatures in some cases hint at something engineered, artificial megastructures or astroengineering systems designed to harness the energy of a central black hole on a scale we cannot imagine. While mainstream science stays far away from the alien hypothesis, the little red dots provide a perfect, ambiguous canvas for such speculation because the natural models are currently failing so spectacularly. Every time we point Webb at a new patch of sky, the ghost in the mirror is there, staring back at us. We are seeing a universe that was loud, fast, and aggressive right from the start. We are seeing black holes that dominate their environments before their environments even exist. And as we refine the data, the flashlight taped to a candle analogy, which was meant to be a comfort, is becoming a warning. It is telling us that the light we are seeing is not the light of a slow, predictable dawn, but the glare of something much older and much more powerful than our current physics can explain. We are looking at a defiance of proportions that suggests our cosmic clock is not just slightly off, it is fundamentally broken. If the black holes are the parents of the galaxies, then everything we thought we knew about the origins of structure, the role of dark matter, and the timeline of the Big Bang must be discarded. We are finding that the early universe wasn't a nursery for infants. It was a kingdom of giants that were already ancient by the time we arrived. The little red dots are the final proof that we are not just looking at the past, we are looking at the fingerprints of a reality that operated under a completely different set of rules, a hidden physics that existed for 1 billion years before stabilizing into the quiet, expanding void we call home today. And as we pull on this thread, the entire tapestry of cosmology is beginning to unspool, revealing an ocean of truth that is bigger, weirder, and far more terrifying than we ever dared to imagine. In the absolute darkness of the primordial void, nearly 13 billion years ago, something technically impossible began to glow. For decades, our textbooks told us that the universe's first light came from the birth of traditional stars, compact balls of gas that ignited through the sheer, crushing pressure of nuclear fusion. But as the James Webb Space Telescope continues to pull back the veil on the cosmic dawn, we are finding evidence of a forbidden phase of history that bypasses the rules of fusion altogether. we are discovering the potential existence of dark stars, monstrous puffy spheres of primordial hydrogen that didn't burn with fire but were powered by something invisible and violent, tearing itself apart deep within their cores. If these objects are real, it means the very first light in the history of our universe wasn't produced by stars as we know them, but by dark matter annihilating itself in a spectacular display of self-destruction. To understand why this is a scientific necessity rather than just a wild theory, we have to look at the universe-breaking crisis Webb has dumped on our doorstep. As we discussed, the telescope is seeing massive, mature objects existing only 300 million years after the Big Bang, a time when the universe was still cooling and organizing itself. Standard physics says that fusion stars simply didn't have enough time to form, grow, and aggregate into the bright cities of light Webb is seeing. The ingredients for efficient cooling weren't there yet. The heavy elements that allow gas clouds to collapse into dense, stellar cores hadn't been forged. In the pristine, metal-free gas of the infant cosmos, the road to fusion was blocked. But Catherine Fries, a physicist at the University of Texas, proposed a cheat code for the universe back in 2007. She realized that while ordinary matter was struggling to condense, dark matter was already there, clumped into dense halos that acted as the gravitational wombs of the first structures. This brings us to the dark star protocol, a mechanism of energy generation that makes nuclear fusion look like a flickering match compared to a forest fire. Dark matter makes up about 1/4 of everything in existence, yet it does not emit, absorb, or reflect light. We only know it's there because its gravity keeps galaxies from flying apart. The leading candidate for this invisible mass is the WIMP, the weakly interacting massive particle. These particles are their own antiparticles. In the high-density environment of the early universe, inside those first dark matter halos, WIMPs would collide with incredible frequency. When a WIMP meets its twin, they don't just bounce off each other, they vanish. They convert 100% of their mass directly into pure energy. For a sense of scale, the fusion that powers our Sun converts less than 1% of its mass into energy. Dark matter annihilation is the most efficient power source imaginable, and in the cosmic dawn, it was potentially fueling the largest objects the universe has ever seen. The scale of these dark stars defies human intuition. They were not the compact, dense spheres of plasma we see in our night sky. They were puffy, diffuse, and unimaginably vast. Imagine a ball of glowing hydrogen so massive that light itself would take several weeks to cross from one side to the other. A single dark star could reach a mass equivalent to 1 million suns and shine 10 billion times brighter than our own star. To put that luminosity in perspective, one solitary dark star could match the light output of an entire small galaxy. If you placed one in our neighborhood, it would swallow thousands of solar systems. It could potentially reach a width 10 times the distance from the Earth to the Sun because their energy source was distributed throughout their entire volume. Wherever dark matter particles happened to meet, they didn't need to compress into a dense core like a fusion star. They were like cosmic fog lit from within, glowing evenly throughout their monstrous structures. This explains why they were able to appear so early in our timeline. They didn't need the slow, painful process of cooling and fragmentation that conventional stars require. They simply gathered gas within a dark matter halo and let the annihilation process take over, reaching a stable equilibrium at densities far lower than fusion would ever permit. This distributed heating allowed them to grow without the structural constraints that cause massive fusion stars to tear themselves apart. They were the pioneers, the first light-bringers in a previously structureless void. And while they lived fast and died young, blazing for perhaps only a few million years, their deaths left behind a legacy that solves our most frustrating cosmic mystery, the origin of supermassive black holes. As we've seen, Webb has discovered billion solar mass black holes existing so early that they shouldn't have had time to grow from seeds of dying stars. The growth rate, limited by the radiation pressure of the Eddington limit, simply doesn't allow for it. But the dark star protocol provides the answer. When a dark star finally exhausts its supply of dark matter fuel, the outward pressure that held it up vanishes instantly. Without fusion to provide a backup source of pressure, the entire million solar mass structure doesn't just collapse, it implodes. Within a matter of days, this object, wider than our solar system, plunges past its own event horizon at freefall velocity. It doesn't leave behind a small seed that needs to grow over eons. It leaves behind a supermassive black hole that is born fully grown. These are the heavy seeds that immediately began devouring the surrounding gas to power the first quasars. The evidence for this is no longer purely mathematical. Webb's spectroscopic instruments have analyzed the light from these ancient little red dots and found a specific absorption feature at 1,640 angstroms. This chemical fingerprint doesn't exist in normal galaxies or fusion-powered star clusters. It corresponds to helium transitions that occur only under the specific temperatures and densities predicted for the outer layers of a dark star. It is what astronomers call a smoking gun, a signal from the past that matches Catherine Freese's predictions almost perfectly. We are finding 4 potential candidates that existed between 300 and 600 million years after the Big Bang, each one displaying characteristics that are inconsistent with conventional stellar physics. This forces us to reconsider the entire narrative of our origins. We were taught that the universe moved from simple to complex in a slow, orderly crawl. But the dark star protocol suggests a much more violent and exotic birth. It implies that the early universe was a loud, aggressive place where invisible matter was being converted into dark light with near-total efficiency. These objects may have been the primary engines of Ryanization, carving out bubbles in the cosmic fog before the first real stars ever turned on. They were the first lights, and they were essentially hybrids, ordinary gas captured and lit by the annihilation of an exotic, invisible substance. If this is true, it changes everything we know about the chemical history of the universe. Dark stars don't produce heavy elements like oxygen and iron because they never undergo fusion. This means the chemistry problem Webb found, heavy elements appearing too early, must have had a separate, equally hyperactive source, or our timeline for star death is even more broken than we realized. It suggests a hidden physics window where multiple formation pathways were competing and cooperating in a chaotic cosmic soup. The most disturbing implication, however, is what it says about our current reality. If the first billion years of time were dominated by objects powered by dark matter, then the laws of physics we see in the night sky today are not the universal constants we thought they were. They are merely the stabilized late-stage versions of a reality that used to run on a completely different engine. We are living in the quiet aftermath of a dark star era that we are only now beginning to detect. The golden eye of Webb isn't just looking at the past, it's looking at a version of our universe that operated under a different protocol. We are finding that the void wasn't empty and the darkness wasn't silent. It was a kingdom of giants, powered by the annihilation of the very matter we still cannot touch, leaving behind a wreckage of supermassive black holes that would eventually go on to rule the centers of every galaxy we can see, including our own. The invisible became the first light, and in its self-destruction, it seeded the world we inhabit today. When we exhaust the limits of what our current physics can explain, we are forced to look beyond the boundaries of our own beginning. For decades, the Big Bang was treated as the ultimate day without a yesterday, a singular, explosive moment where time and space were birthed from nothingness. But as the James Webb Space Telescope continues to pull fully formed, mature galaxies out of the darkness of the cosmic dawn, the idea of a single, clean beginning is starting to feel like a beautiful lie. If our universe didn't have enough time to build these giants, perhaps it's because it didn't have to. This brings us to one of the most mind-bending figures in modern science, Sir Roger Penrose. Penrose is a legend, a man who won the Nobel Prize for proving that black holes are an inevitable consequence of Einstein's theories, but he has spent his later years championing a theory that treats our Big Bang not as a birth, but as a reincarnation. He calls it conformal cyclic cosmology, or CCC, and it proposes that our universe is just one link in an infinite chain of aeons. In Penrose's vision, the universe is like a phoenix endlessly being reborn from its own ashes. To understand how this works, you have to imagine the terrifyingly distant future of our own reality. Trillions of years from now, long after the last stars have flickered out and even the black holes have evaporated into a thin mist of radiation, the universe will be essentially empty. In this state of maximum boredom, there is no matter left to keep track of time or scale. When there are no particles with mass remaining, the universe loses its ability to distinguish between massive and tiny, or short and long. Penrose mathematically demonstrates that at this point, the vast, cold, infinitely expanded future of a dying universe becomes identical to the hot, dense, concentrated Big Bang of the next. The end of one cosmic era triggers the birth of another in a seamless phase shift. This radical framework provides the perfect solution for the impossible galaxy problem that has left JWST astronomers in a state of quiet panic. If we see a galaxy like JADES-GS-Z14-0, a massive, chemically enriched monster existing only 290 million years after the Big Bang, we no longer have to struggle with the math of how it grew so fast. Under CCC, these objects aren't universe breakers because they were built in record time. They are artifacts of a lost aeon. They are the wreckage of a previous world that managed to survive the transition into our own. Imagine our Big Bang as a massive flood that wiped the slate of reality clean. Penrose is suggesting that these galaxies are the stone ruins of a pre-flood civilization, still standing amidst the rising waters of our new cosmos. They got a cosmic head start because they were already partially assembled in the aeon that came before ours, seeded into the foundations of our reality like fossil structures from a forgotten history. But Penrose isn't just offering a philosophical comfort, he is pointing to a physical fingerprint left on the sky. He argues that if this cycle is real, then the most violent events of the previous universe must have left a mark on our own. Specifically, he looks at the supermassive black holes of the prior aeon. As those ancient monsters slowly evaporated through Hawking radiation over unimaginable spans of time, they would have released concentrated bursts of energy. When the universe transitioned into our current Big Bang, those bursts would have been compressed into tiny, intensely hot points. Penrose and his team claim to have found these marks in the cosmic microwave background, the afterglow of our own beginning. They call them Hawking points. These Hawking points are described as faint, circular bruises in the radiation of the early universe. They are the thermal ghosts of black holes that died billions of years before our stars were even a thought. While the wider scientific community remains locked in a fierce debate over whether these circles are real or just statistical noise, the discovery of little red dots by Webb has reignited interest in the theory. If the early universe is indeed dotted with hundreds of compact, impossibly massive black holes, then we are no longer looking at a simple growth story. We are looking at a population of survivors. Some theorists speculate that the little red dots might be the physical manifestation of these Hawking points, actual matter that gathered around the bruises left by the previous universe's black holes. It would mean the monsters JWST is finding weren't born in our universe, they were inherited. This relic theory fundamentally changes the narrative of our origins from one of evolution to one of archaeology. If Webb is seeing galaxies that are 13.5 billion years old in a universe that is only 13.8 billion years old, the margin for error is non-existent. But if we are living in a nested or cyclic reality, then time as we measure it is a local illusion. Those impossible galaxies are the stone and steel skyscrapers found in the ancient ruins of our dawn, proving that the cosmic clock is misaligned because we are only looking at one chapter of a much longer book. Penrose's warning, much like Adam Rees's, suggests that our standard model is a local map that fails the moment you reach the edge of the territory. We aren't seeing the first stars, we are seeing the reflections of a lost aeon, the artifacts of a universe that lived, breathed, and died long before our own light was ever switched on. The existence of these relics would imply that the Big Bang was not a creation out of nothing, but a phase shift from a parent reality. This provides a terrifying sense of scale shock. It means the empty void we see between the stars is actually the diluted graveyard of 1 trillion previous civilizations. Every impossible galaxy Webb captures is a message from that graveyard, a signal that reality operates on a much faster, much more violent rhythm than our gentle textbooks ever allowed. We are finding that the cosmic dark ages weren't a time of quiet formation, but a thunderous awakening where the wreckage of the past was being recycled into the giants of the present. The little red dots, the mature spirals, and the universe breakers are the final proof that we misunderstood the beginning because we assumed we were the first to be here. As we peer deeper into these bruises in the background radiation, the existential horror begins to set in. If our universe is just one aeon in an endless cycle, then the laws of physics we cherish aren't universal constants. They are just the temporary settings of the current aeon, stabilized artifacts of a reality that used to run on a completely different engine. The hidden physics window of the first billion years, the era of dark stars and super Eddington black holes, might have been the final echo of the previous universe's rules before our own version of reality finished rendering. We are living in the quiet aftermath of a cosmic transition, looking through the golden eye of Webb at a mirror that reflects a history we were never supposed to witness. The impossible light of the cosmic dawn isn't just the birth of our world, it is the last dying glow of the world that came before, a ghost in the mirror that reminds us that in an infinite cycle, nothing is ever truly new, and nothing is ever truly lost. If we were to zoom out from the individual monsters of the early universe, past the dark stars and the little red dots, we would find that these objects are not drifting in a chaotic, random void. For decades, our standard models suggested that the early universe was a disorganized mess of gas, but the James Webb Space Telescope has revealed something much more structured, and frankly, much more disturbing. We are now seeing that galaxies are actually the beads on a vast, invisible string connected by enormous filaments of gas and dark matter that stretch across hundreds of millions of light years. This is the cosmic web, the largest known structure in existence, a giant glowing spiderweb that defines the architecture of our reality. According to the textbooks, this web was supposed to be a work in progress during the cosmic dawn, a faint and fragile network that would take billions of years to fully mature. But when Webb turned its infrared gaze toward the deepest slices of time, it found the web already finished, as if the blueprint of the universe was executed in a single, violent stroke. In the standard model of cosmology, the universe builds itself from the bottom up, with dark matter clumping together first to form the gravitational seeds where galaxies eventually grow. Simulations predicted that in the first few 100 million years, we should only see small, isolated pockets of structure, scattered outposts in a dark wilderness. Webb, however, has exposed a clustering pattern that simply does not match those predictions. Astronomers have now mapped long, elegant filaments connecting galaxies across distances that should have been physically impossible at that age. Some of these filaments stretch across millions of light years, already thin and refined, appearing in a cosmic era when the universe was supposed to be too young to support such large-scale organization. A team at Tokyo University, after analyzing some of the first major datasets, concluded that these filaments were already organizing the cosmic landscape into a sophisticated scaffolding, while the galaxies themselves were still in their infancy. This discovery exposes what we might call the ultimate law gap in our understanding of creation. In our old stories, the body of the universe, the galaxies and the stars, grew alongside its skeleton, the dark matter filaments. But Webb is showing us a top-down reality where the skeleton was grown before the body was even finished. This implies that dark matter was pulling gas and energy together at an extraordinary speed, far faster than any of our current models of gravity or particle physics can allow. The universe wasn't building itself slowly, it was being woven together with a precision and connectivity that suggests the skeleton was seated into the foundations of space-time before the first light ever switched on. It is as if the universe arrived at the Big Bang with a pre-existing infrastructure already in place, an invisible architecture that dictated exactly where every galaxy would eventually sit. But as we map this skeleton, we are discovering that the bones themselves are crooked. This leads us into one of the most controversial and unsettling puzzles in modern science, the rotation puzzle. For nearly a century, the cornerstone of cosmology has been the principle of isotropy, the idea that the universe, on a large enough scale, looks the same in every direction. We assumed there was no up, no down, and no preferred orientation in the void. We expected that if we looked at the spin of galaxies across the sky, they would be perfectly balanced. Roughly half would spin clockwise, and the other half would spin counterclockwise. But Webb is helping to confirm a suspicion that has been growing in the dark. The spin is not random. When researchers studied vast samples of galaxies across enormous distances, they noticed a persistent and undeniable discrepancy. Galaxies seem to have a slight but statistically significant preference for one rotational orientation over the other. This asymmetry is not a localized glitch. It persists even when you strip away every potential bias and observation error. A team at Kansas State University has confirmed that this cosmic tilt exists across multiple regions of the sky, suggesting that the universe itself has a preferred direction, a hidden alignment that influences the very motion of matter. If galaxies are rotating in a non-random way, it implies that something fundamentally broke the symmetry of the universe in its first few milliseconds. One of the most provocative theories to emerge from this data is that the universe itself might be rotating. If the entire cosmos is spinning slowly on a scale so massive we can barely comprehend it, then every galaxy inside it would inherit that subtle, directional bias. This would mean the universe is not a uniform, expanding balloon, but a structured, biased engine with a cosmic tilt that dictates the flow of time and matter. This tilt connects back to the filaments of the cosmic web in an eerie way. Webb has revealed that some of these enormous filaments extend in unusual directions, showing alignments that hint at large-scale anisotropies, features in space that prove one direction is not like the others. We are finding that the cosmic skeleton was built with a bias, and that bias is now being reflected in the rotation of every galaxy we observe. It suggests that the universe isn't just an accidental explosion, it is an architecture with a preferred orientation, perhaps seeded by the rotation of a parent universe or the conditions of the black hole we might be living inside. The existential weight of this cannot be ignored. If there is a preferred direction in the universe, it means that our fundamental laws of motion and gravity, which assume a uniform, symmetrical reality, are incomplete. We are seeing a skeleton that was built too fast, and a body that is spinning with a bias we never predicted. The early universe was not a quiet, gradual awakening. It was a thunderous, aggressive, and highly organized event that followed a blueprint we are only now beginning to read. As we pull on these threads of large-scale structure and rotational bias, the standard model of a random, isotropic Big Bang begins to look more like a simplified fairy tale. We are discovering that we live inside a universe with a distinct tilt, a skeleton that preceded its own creation, and a hidden orientation that suggests our reality is just a small, biased fragment of a much larger and more complex architecture that we have only just begun to name. We have spent this journey staring at the wreckage of our own beginning, but what if the wreckage we are seeing doesn't actually belong to us? As the James Webb Space Telescope pushes the boundaries of the observable horizon, it is increasingly clear that the impossible galaxy problem might not be a problem with our math, but a problem with our boundaries. We have treated our universe like a sealed room, a closed box containing everything that has ever existed. But the data is starting to suggest that there is another universe in the room with us. This is the terrifying realization that our Big Bang might have been just one isolated bubble of creation in an eternally inflating, infinitely vast superspace. In this framework, the cosmos is not a single, lonely event, but a roiling ocean where new universes are popping into existence like bubbles in a boiling pot. each carrying its own unique set of physical laws. The standard model tells us that inflation happened once, a rapid burst of expansion that smoothed our reality and then stopped. But the law of eternal inflation suggests that the process never actually ended. It only stopped in our local neighborhood, leaving us drifting in a vast sea of other realities. This provides a provocative answer to why Webb is seeing galaxies that are too bright, too massive, and too evolved for their age. If these objects are not homegrown products of our own Big Bang, they could be the scars or wounds left behind by a multiverse collision. Imagine two massive bubbles in a superspace bumping against each other. That impact would leave a cosmic bruise on the afterglow of our beginning, a permanent mark in the background radiation where a neighboring cosmos bled into our own. These bright, early structures, these universe breakers that defy every rule of our physics, might be the literal aftermath of a neighboring reality leaking through the cracks of our dawn. Instead of seeing the first stars of our world, we might be witnessing the physical contamination of an external reality. This would mean that JADES-GS-Z14-0, that monster galaxy appearing just 290 million years after the Big Bang, isn't just an impossible object. It is an intruder. It represents a hidden physics window where for the first few 100 million years, our reality was intermingling with a neighboring one, operating under temporary laws that allowed for structures to form at speeds we cannot reproduce today. This theory suggests that the crisis in cosmology isn't a failure of our scientists, but a natural result of looking at the seam of our reality. If we are seeing objects that formed too fast, it may be because they were forged in a neighboring bubble where time flows differently or where gravity is fundamentally stronger. When we look back 13.5 billion years, we aren't just looking at the past, we are looking at a collision zone. The other universe is not a far-off fantasy. It is the source of the anomalies that are currently dismantling our textbooks. We are staring at a wound in space-time where the blood of another cosmos is glowing in our infrared cameras. But the other universe might not be sitting next to us in a superspace, it might be the very house we live in. This is the black hole cosmology theory, the idea that our entire reality, every star we see and every breath we take, is contained entirely inside the event horizon of a black hole in a parent universe. In this nested universe, or Russian doll hypothesis, what we call the Big Bang was not a beginning from nothingness, but a phase shift from a parent reality. It was the moment a massive star in another universe collapsed, and as its matter plunged past the event horizon, it didn't just vanish, it created a new, four-dimensional bubble of space-time within it. This creates a sense of scale shock that dwarfs every other mystery we have explored. It suggests that our observable universe is just a local cell inside a vastly larger organism. Under this framework, the little red dots Webb is finding everywhere in the cosmic dawn are not just galaxies or black holes, they are the umbilical cords of our reality. These compact, ultra-luminous objects that outshine entire galaxies might be the physical link between our reality and the parent cosmos, the points where matter and information are still bleeding through the horizon to seed the structure of our world. If this is true, then the impossible galaxies are not impossible at all. They are just inherited. They are the fragments of the parent universe that managed to survive the collapse, providing the cosmic head start that allowed our early structure to form before our own clocks had even started ticking. The existential horror of this realization is that the laws of physics we have spent centuries mastering are just the temporary settings or the software of the black hole we inhabit. We are living in a stabilized version of a much more violent, much faster original reality that existed in the parent cosmos. The Hubble tension, the crisis of cosmic time, and the universe breakers are all just rendering artifacts or glitches that occur because we are trying to measure a system that is fundamentally nested within another. Our reality is a simulation of sorts, not necessarily a digital one, but a physical one, optimization, shortcuts and all, playing out inside the heart of a cosmic monster. When Nobel laureates like Adam Rees warn that we have misunderstood the universe, they are acknowledging that our map is not the territory. We have been drawing a map of a single island only to realize that the island is just a speck of dust on the back of a giant whale. The other universe in the room is the realization that our scale is not the absolute scale. We are finding that the void between the stars isn't just empty space, but the diluted graveyard of 1 trillion previous civilizations and universes that came before us. Every impossible signal Webb captures is a mirror reflecting a reality that is far older, faster, and more terrifying than we were prepared to believe. This leads us to a disturbing pivot in our understanding of time. If we are living inside a black hole, then time is not a universal constant, but a local illusion governed by the rotation and expansion of our parent horizon. The galaxies that Webb sees as mature adults at the dawn of time are not miracles. They are the survivors of the scale shock. They are the physical proof that our Big Bang was just a transition, a violent phase shift from a mother universe that is still out there, just beyond the reach of our light. We are the inhabitants of a Russian doll universe, peering through a golden eye at the walls of our own cage. The little red dots are the final glowing evidence of this connection. By outshining entire galaxies while being a fraction of their size, they defy the cosmic law of proportions because they are not following our proportions. They are following the proportions of the parent universe. They are the fingerprints of a reality that operated under a completely different set of rules, a hidden physics that existed for 1 billion years before our world finally rendered into the quiet, stable void we know today. As we pull on this thread, we are finding that the universe didn't just start 13.8 billion years ago. It inherited its bones, its bias, and its monsters from a reality that was ancient before our light was ever switched on. We are standing at the edge of a scientific revolution that is moving from astronomy into archaeology. We aren't just looking at stars, we are looking at the ruins of a pre-Big Bang reality. We are finding that the cosmic dark ages were actually a thunderous awakening where the wreckage of the past was being recycled into the giants of our present. The other universe is not a theory anymore. It is the only explanation that fits the impossible things Webb is seeing. The golden eye has opened a door we can never close, and as we look through it, we find that we are not the first, we are not the only, and we are certainly not the largest thing in the room. We are just a local bubble in an endless ocean, a single chapter in a book that is far too big for us to ever finish reading. If the structure of the cosmic web is the universe's skeleton, and the supermassive black holes are its heart, then chemistry is its blood. Every atom in your body, from the iron in your blood to the oxygen filling your lungs, has a birth certificate written in the fires of a dying star. This is one of the most sacred rules in astronomy. The early universe was chemically pristine, containing only the simplest elements of hydrogen and helium. Everything else, the metals of the periodic table, had to be cooked, seasoned, and scattered across the void over eons of stellar birth and death. But when the James Webb Space Telescope looked at the first galaxies, it didn't find a pristine laboratory of simple gas. It found a polluted, mature, and chemically complex landscape that defies every law of the cosmic timeline. We have stumbled upon the wrong chemistry, and the implications suggest that the first billion years of time operated under a hidden physics window that has since slammed shut. To understand why this discovery is so disturbing, you have to appreciate the sheer amount of time that chemistry is supposed to take. In the standard story, the first generation of stars, the legendary population 3 giants, had to form from pure hydrogen and helium. These stars had to live their brief, violent lives, forging slightly heavier elements in their cores, and then explode as supernovas to seed the surrounding space. Then a second generation of stars had to form from that enriched gas, cooking even heavier elements like oxygen, carbon, and eventually iron. According to our most advanced models, this recycling process should take at least 1 to 2 billion years to produce a meaningful chemical signature. You cannot have a chemically advanced galaxy without multiple generations of ancestors. Yet James Webb turned its mirror toward JD's GSZ140, a galaxy captured just 290 million years after the Big Bang and found the unmistakable chemical fingerprint of oxygen. This shouldn't just be a surprise, it should be a physical impossibility. Finding oxygen in a 290 million-year-old galaxy is like entering a nursery and finding a newborn baby who has somehow already lived several full lifetimes. For oxygen to exist in such abundance so early, the parents and grandparents of that galaxy must have lived and died in a heartbeat, compressing 1 billion years of evolution into a fraction of the time. But the mystery didn't stop with oxygen. In other deep surveys, Webb detected traces of iron, carbon, and silicon in galaxies that were less than 500 million years old. Iron is the ultimate late-stage element. It is the final ash of the nuclear furnace, the element that signals the end of a star's life. Finding iron in the cosmic dawn is a signal that the universe didn't crawl through its early years. It sprinted. It tells us that the early universe was a high-speed chemical factory, recycling matter at a rate that current physics cannot easily explain. This leads us to the even more baffling problem of impossible dust. To a human, dust is a nuisance on a shelf, but to an astronomer, cosmic dust is the most important substance in the universe. It is the building block of rocky planets, of mountains, and of life itself. Without dust, there are no Earths. Standard physics says that cosmic dust takes hundreds of millions, if not billions, of years to accumulate as stars slowly cool and shed their outer layers. The earliest galaxies were expected to be clean and pristine, glowing with the pure blue light of young stars. Instead, Webb found galaxies only a few 100 million years old that were already choked with dust, so much of it that their light was muffled and reddened, much like the mature, dusty galaxies we see in the modern universe. If dust was already abundant in the cosmic dawn, it means that planets could have formed billions of years earlier than we ever imagined. It means the conditions for chemistry, and potentially life, may have appeared while the universe was still in its infancy. But it also means that our entire understanding of how matter matures is fundamentally flawed. We are seeing a chemically advanced universe from the very start, which forces us to ask, how did the universe cook its ingredients so fast? The answer, hidden in the most provocative corners of the law vault, is the theory of the hidden physics window. This theory proposes that for the first billion years after the Big Bang, the laws of physics were not the stable, universal constants we know today. Instead, we may have been living in a volatile era of reality, a phase where the settings of the universe allowed for a flash of super-efficient galaxy building and chemical recycling that we can no longer observe or replicate in the modern age. Imagine the universe as a piece of software that was recently booted up. During that first billion years, the physics engine might have been running at a higher clock speed, or with different parameters. Perhaps gravity was stronger, or the way matter interacted with radiation allowed for a boiling point, where heavy elements were forged and distributed with near-total efficiency. This would explain why Webb sees impossible galaxies and wrong chemistry. We are looking back at a version of reality that was operating under a temporary set of rules. Under this hidden physics framework, the current universe we inhabit, the one where stars take billions of years to evolve and chemistry moves at a slow, predictable pace, is merely the stabilized, late-stage version of a reality that used to run on a much more violent and aggressive rhythm. We are living in the quiet aftermath of a cosmic sprint. This would mean that the laws of physics we cherish aren't universal constants at all. They are just the stabilized settings of the current aeon. But there is an even more disturbing implication to the wrong chemistry found by the golden eye of Webb. If the heavy elements like iron and oxygen are appearing too fast, it suggests that the cosmic clock we use to measure time is fundamentally misaligned. If we find a modern skyscraper in a 500 million-year-old layer of time, it might not be because they built it fast. It might be because that layer of time isn't actually 500 million years old. This is where the scientific tension turns into existential dread. If we have misunderstood the chemistry of the early universe, we have misunderstood the age of our reality. Some theorists, as mentioned in the law vault, are starting to view these chemical anomalies as rendering artifacts, clues that our reality is an optimized system where the early stages were rendered with shortcuts that create inconsistencies when measured by late-stage observers. It suggests that the wrong chemistry isn't an error in the stars, but a glitch in the code of the cosmos itself. The oxygen and iron shouldn't be there because the system hadn't had enough cycles to produce them. Yet there they are, preloaded assets from a reality we don't fully understand. Whether these elements are relics of a previous universe bleeding through or the result of a hidden physics window where gravity and time flowed differently, one fact remains. The early universe was not the simple, quiet nursery we were promised. It was a kingdom of mature giants, recycling matter and forging the ingredients of life with a speed and aggression that terrifies our current models. We are standing at the threshold of a scientific revolution that doesn't just want to rewrite the textbooks, it wants to dismantle our very definition of what is possible. We thought we were measuring the dawn of stars, but we are actually finding that the void was already full of the ashes of a history we weren't supposed to witness. The wrong chemistry is the final evidence that we are not the first to be here, and the universe did not wait for us to begin its work. We are living in a reality that was already ancient by the time we were born, and the golden eye of Webb is finally showing us the scars of that forbidden past. As we stand amidst the wreckage of our most sacred cosmological models, we are forced to confront a possibility that is far more disturbing than a simple math error or a misaligned telescope. For decades, we believed we were uncovering the objective, physical laws of a base reality, but the deeper James Webb peers into the dawn of time, the more the universe begins to look like a construct that is failing to hide its own seams. We have found galaxies that are too massive, black holes that are too ancient, and chemistry that is too advanced, but these are merely the symptoms. The underlying disease is a persistent, undeniable inconsistency in the very numbers that define our existence. In the private circles of theoretical physics, an unsettling argument is gaining traction that the crisis in cosmology is not a failure of our instruments, but a series of rendering errors in a computational system. We are seeing bugs in reality, and the realization is setting in that the laws of physics might not be universal constants, but rather software settings that have begun to glitch under the scrutiny of our most powerful eye. This existential horror begins with a number you've likely never heard of, but one that is quietly breaking the framework of reality, the S8 tension. If the Hubble tension is the loud crisis of how fast the universe is expanding, S8 is its quiet, more disturbing sibling. It measures exactly how clumpy the universe is, how much matter has gathered into dense knots of galaxies versus how smoothly it is spread across the void. According to the standard model based on the initial conditions of the Big Bang, gravity should have pulled the universe into a specific level of jagged, structural complexity by now. But when we measure the actual distribution of matter, we find that the universe is too smooth. It's as if the physics engine of our reality failed to fully render the fine details of the cosmic web, leaving the universe in a state of lower than expected resolution. In any other context, we would call this an optimization shortcut, a way for a computer to save processing power by smoothing out the background textures where it thinks no one is looking. But the rendering error argument becomes truly terrifying when you pair the smoothness of S8 with the violence of the Hubble tension. As we have explored, the universe appears to be expanding at two different speeds depending on where you look. When we look at the ancient afterglow of the Big Bang, the blueprint says the expansion rate is 67, but when we look at the real burning stars of the present day, the ruler says 73. This 6% gap is a chasm that cannot be crossed by standard physics. In the framework of simulation theory, this is what happens when two separate modules of a digital system fail to sync. It is a computational inconsistency where the initial state of the simulation and its current output no longer match because the system is struggling to process the sheer amount of data that a 14-billion-year-old reality has generated. The Hubble tension is the moment the glitch in the matrix becomes impossible to ignore. If different measurements of the same reality give different answers, the most logical and most haunting explanation is that we are looking at rendering artifacts. Think of a high-end video game. When you are far away from a mountain, the computer renders it as a simple, smooth shape to save memory. It is only when you get closer that the system pops in the rocks, trees, and detail. For centuries, our telescopes were not powerful enough to see the pop-in of the cosmic dawn. We saw a smooth, predictable story because we were looking at the low-resolution version of the universe, but James Webb has brought us too close to the screen. By peering back to within 300 million years of the beginning, we have forced the system to render the most complex, high-energy era of history with a level of detail it was never optimized to handle. The impossible galaxies and universe breakers we see are the artifacts of the system trying to catch up, mature, fully formed assets being dropped in to a timeline that shouldn't contain them because the simulation is lagging. This leads us to the most provocative idea found in the law vault, the hidden physics window. We have struggled to explain why the early universe was a high-speed chemical factory that forged oxygen and iron in a heartbeat, or why little red dots outshine entire galaxies. The simulation argument suggests that the first billion years of time were actually a boot-up sequence. During this era, the physics engine was running on different parameters, higher clock speeds, stronger gravity, or altered constants that allowed for the rapid assembly of the cosmic skeleton. Once the primary structures were in place, the system stabilized into the quiet, predictable laws we measure today. We perceive this as a crisis in cosmology, but it might just be the transition from a high-performance setup phase into a long-term, power-saving stable state. Our universal constants are nothing more than the software settings that the system eventually settled on. The existential horror of this realization is that it strips away the idea of a natural world. If the laws of physics are just variables in a script, then reality is not locally real, a conclusion that recent Nobel-winning experiments have already begun to suggest. We are living in a Russian doll or nested universe, where our Big Bang was actually a phase shift from a parent reality, a virtual machine running inside another, larger computer. The little red dots aren't just galaxies, they are the umbilical cords of information bleeding through from the parent system to seed the structure of our own. This creates a sense of scale shock that makes our entire history feel like a flickering shadow on a wall. We are the inhabitants of a construct that is starting to show its age, peering through a golden eye at the walls of our own cage and realizing that the last theory of everything might not be a discovery of nature, but an act of reverse engineering the code. Every time Adam Rees warns that we have misunderstood the universe, he is pointing toward the cracks where the code is visible. The 6% gap in the expansion rate is the signature of a system that is fundamentally misaligned. The cosmic tilt and the rotation puzzle suggest that the universe has a preferred direction, a hidden bias that acts like the up axis in a 3D modeling program. We are finding that the void is not empty space, but the graveyard of a trillion previous renders and aeons that came before us. We are not the first to live in this construct, and we are certainly not the largest thing in the room. We are just a local bubble in an endless ocean of data, a single chapter in a book that was already ancient by the time we learned to read the first page. The final image James Webb presents is not one of a beautiful, orderly dawn, but of a reality that is finally speaking back. The impossible light of the cosmic dawn is the glare of the system's limits. We thought we were measuring the birth of stars, but we are actually witnessing the rendering errors of a universe that is far older, faster, and more terrifying than we were prepared to believe. The wrong chemistry and the universe breakers are the final proof that we are standing at the threshold of a scientific revolution that will move from astronomy into archaeology, a desperate attempt to piece together the rules of the world that existed before our own light was ever switched on. We are living in the quiet aftermath of a cosmic transition, and as we look through the golden mirror, we are finding that the glitch is not in the telescope, but in the very foundations of the reality we call home. The crisis is not that we are wrong, It's that we are finally starting to see the truth, and the truth is that our universe is a construct whose software is finally starting to fail. We have reached the end of the cosmic map, only to find that the territory is far more vast, strange, and terrifying than the paper it was drawn on. For decades, the standard model of cosmology was our primary source of comfort, a 13.8 billion-year-old history book that we believed was almost finished. We thought we were merely filling in the final few pages of a slow, predictable assembly of stars. But as the James Webb Space Telescope continues to pull mature, fully built giants out of the darkness of the cosmic dawn, we are forced to admit that the picture on the box does not match the puzzle we are actually building. This realization is not a failure of our science, it is the death warrant for our old certainty and the birth of a new scientific revolution. History has taught us that every time the universe seems broken, it is actually just trying to show us a larger truth. In the 1920s, the first measurements of the Hubble constant were so far off they made the universe appear younger than the Earth, a contradiction that split the field in half. In the 1990s, we faced a similar crisis where the expansion of space seemed to defy the pull of gravity, a flaw that eventually led to the discovery of dark energy. What looked like fatal errors in the past turned out to be the doors leading to the next version of reality. Today, the universe breakers, the little red dots, and the wrong chemistry are those same stress marks tracing the outline of a reality that is finally expanding beyond our ability to simplify it. We are witnessing the collapse of a scientific empire of ideas. The Hubble tension, that persistent 6% gap between the past and the present, is no longer a tension or a problem. It is a full-blown cosmic crisis. It is the signature of a system that is fundamentally misaligned, a rendering artifact appearing at the seams where our local measurements meet the ancient blueprint of the Big Bang. If Nobel laureates like Adam Rees are warning that we have misunderstood the universe, it is because we are starting to see the cracks where the code is visible. We are finding that the void between the stars is not just empty space, but potentially the diluted graveyard of a trillion previous aeons or a neighborly wound where another cosmos is bleeding into our own. The transition we are experiencing moves us from being observers of astronomy to practitioners of cosmic archaeology. We are no longer just measuring the light of stars, we are digging through the ruins of a pre-flood reality, finding impossible galaxies like JADES-GS-Z14-0 that stand like stone skyscrapers in the middle of a primitive dawn. We are uncovering a hidden physics window where, for the first billion years, the laws of nature ran at a different clock speed, powered by the annihilation of dark matter in monstrous dark stars, or the recursive expansion of a universe nested inside a black hole. Every anomaly Webb captures is a signal that we were never the first to be here. Our Big Bang was likely not a beginning from nothingness, but a phase shift from apparent reality, a violent, thunderous awakening that recycled the wreckage of the past into the giants of our present. This is the forbidden knowledge that humanity has spent centuries avoiding. We wanted a universe that was small enough to fit into our equations, a reality that was locally real and followed a slow, orderly crawl toward complexity. But the golden eye of Webb has stripped away that illusion. It has shown us that the laws of physics we cherish are merely the temporary settings of our current aeon, the stabilized late-stage versions of a reality that used to operate under a completely different protocol. We are standing at the threshold of the last theory of everything, realizing that we are just a local bubble in an endless ocean of data, a single chapter in a book that was already ancient by the time we learned to read the first page. There is a profound existential weight to this moment, a scale shock that makes our entire history feel like a flickering shadow on a wall. We are the inhabitants of a construct that is starting to show its age, peering through a gold-plated mirror at a universe that is far older, faster, and more terrifying than we were prepared to believe. But there is also something magnificent in our curiosity. We are a conscious arrangement of atoms, forged in the very star deaths we are now studying, using math and mirrors to argue about whether reality is expanding 6% faster than it should be. We have reached the boundary of what we know, and instead of turning back, we have decided to keep pushing into the dark. We thought we were using James Webb to fill in the last few pages of our cosmic history book, but in a twist no one saw coming, the telescope hasn't just given us new answers, it has thrown out our old questions and replaced them with ones that are way stranger. It has shown us that the cosmic dark ages weren't a time of quiet formation, but a kingdom of mature giants already chemically advanced and structurally finished. The wrong chemistry and the universe breakers are the final evidence that the universe did not wait for us to begin its work. We are living in a reality that was already ancient by the time we were born. As we look toward the future, the mood in the scientific community is not one of panic, but of productive anxiety. We are like a species on a small, rocky planet finally realizing that our map is not the territory. We have been drawing the map of a single island, only to find the island is a speck of dust on the back of a giant whale. The Hubble tension is the signature of that misalignment, the glitch in the matrix that confirms the ground beneath our feet is liquefying. But as the empire of our old ideas collapses, it leaves behind the debris of a much larger and more beautiful truth. The journey to fix our broken understanding has only just begun. New instruments like the Nancy Grace Roman Space Telescope and the Euclid mission are already joining the search, designed specifically to probe the wounds in space-time and the rendering errors in our code. We are moving toward a 21st century rewriting of cosmology that will rival the arrival of quantum mechanics. We are preparing for answers that may feel more like science fiction than science, as we stand at the edge of an ocean bigger and weirder than we ever imagined. The final image of this journey is not one of a silent, empty void, but of a golden eye looking back at us. The James Webb Space Telescope, floating 1,000,000 miles away in the cold dark, is more than just a tool. It is a mirror reflecting a universe that is finally speaking back. It is telling us that the impossible light of the cosmic dawn is actually the glare of the system's limits, the last dying glow of a world that came before ours. We thought we were the first to look into the darkness, but we are finding that the darkness has been watching us the entire time. The mirror is no longer showing us our past, it is showing us our boundaries, revealing that we are just a local cell inside a vastly larger organism, peering through the walls of our own cage. And as that golden mirror catches the light of galaxies that shouldn't exist, we realize that the mystery is far from over. It has simply grown large enough for us to finally see it. The universe isn't broken, our understanding is, and the version of reality we are about to uncover will be stranger and more beautiful than anything we have ever drawn.